Good evening, everyone. So today we start a very important topic. Today we start a very important topic. We start dielectric medium. So basically, what do you mean by that dielectric medium? Dielectric. See, we know if we insert some medium, so then its electric field, its electric force change, even capacitor also change. Epsilon naught A by D become epsilon naught epsilon R A by D, and sometime that epsilon R we can say K, that is the dielectric constant. So basically dielectric constant is a medium, and this is a special type of medium. So dielectric medium are which special type of medium? Dielectric mediums has basically two types. One is the polar compound, another one is the non-polar compound. Non-polar. One is the polar, another one is the non-polar compound. So some example of polar compound like water, NH3, PH3, then keto group, then aldehyde group, CHO, etc. What about the non-polar compound? So you can write here CCl4 also. Sorry. CHCl3. That is the, I think, chloroform, right? Hello.
Yes.
Now, non-polar compound, carbon dioxide, CCl4, then CH4, then C2H6, etc. Now see, in polar compound, it's a partially positive and partially negative. So no problem with this polar compound. We know, yes, it's a partially positive and partially negative. But in case of non-polar compound, like suppose if we use...
Sir, started the third chapter.
No, second chapter. Second chapter.
Capacitor.
Okay, so if we use CCl4, carbon, chlorine, we know chlorine is electronegative than carbon. So del minus, del plus, del minus, del plus, del minus, del plus, del minus, del plus. So the direction of dipole negative to positive, direction of dipole negative to positive, direction of dipole negative to positive, direction of dipole negative to positive. So if we want to calculate the overall, as dipole is a vector quantity, so net dipole moment is 0. In chemistry or for this chemical part, we use this as a mu. You can use it as a p also. So dipole moment is 0. So what do you mean by that? Center part is positively charged and the side one is negative. Acha. So what happened? This is the center part, and in the center you have all the partially positive charge, and these are the negative charge at the corners. So overall the dipole moment is 0. Now see what happened. If we introduce it in presence of external electric field, so negative charges are moved in the opposite direction. We know this. And positive charges move in the opposite direction, or positive charges move in the same direction of electric field. So what happened? In presence of electric field, now they are rearranged, and all the positive charges are in the direction of electric field, and all the negative charges are in the opposite direction. So it produces an induced electric field. So now the net electric field is external minus induced electric field. Is it clear, everyone? Hello. Now see what happened. So in exam, examiner can ask you like give 2 example of polar compound, 2 example of dipolar non-polar compound. So you can write this. You can use chemical compounds also. You know polar, non-polar in chemistry also. Okay. So now suppose we have a parallel plate capacitor. So this is the plus plate and this is the minus plate. In this parallel plate capacitor, if we introduce this dielectric medium, so what happened? They are partially charged in presence of external electric field. Means when you connect it with the battery, this one is plus Q, this one is minus Q. That means you are creating an external electric field, and due to that external electric field in the dipole, what happened? They are partially charged and they are arranged. So now in the direction of the dipole electric field, partially positive charge and they are partially negative charge. E induce plus minus plus minus plus minus plus minus minus minus. So overall, electric field induce net induce electric field. So net electric field is external electric field minus induced electric field, and we know that dielectric constant or relative permittivity, which still now we say relative permittivity, and from now we can say dielectric medium, because dielectric medium are a special type of medium, polar and non-polar compound. Otherwise, for the generalized form, it's a relative, right? So this dielectric constant K is external electric field by induced electric field or net electric field. So we can say external electric field upon E minus E induce. So we know for external electric field for parallel plate capacitor, electric field is sigma by epsilon naught. So E is sigma by epsilon naught. And as it is the induced, so we can write sigma induced by epsilon naught. Now this epsilon, epsilon, epsilon we can cancel. So dielectric constant is sigma by sigma minus sigma induced. Sigma induced is the charge induced on the dielectric medium. So K sigma minus sigma induced is sigma. So K sigma minus K sigma induced is sigma. So K sigma induced is sigma K minus 1. So sigma induced is sigma 1 minus 1 by K. So area into sigma induced, area into sigma 1 minus 1 by K. So charge induced is charge 1 minus 1 by K. What do you mean by this charge? This is the initial charge, means in the absence of this medium, means this dielectric medium. So you can say this charge is initial capacitance into voltage is your initial charge. So you can note down this. I think you understand that part. Sometimes they can ask you charge, sometimes they can ask you charge density. So very simple, divided by area, you get the charge density. So once you're able to find out the charge, how to find out the charge, it's very obvious to find out the charge. Please write a question. A capacitor of capacitance 50 microfarad, a capacitor of capacitance 50 microfarad, comma, charged with a battery of 4 volt, a capacitor of capacitance 50 microfarad charged with a battery of 4 volt, full stop. After full charge, disconnect battery. After full charge, disconnect battery and insert a dielectric slab with dielectric constant K equals to 4. After full charge, disconnect battery and insert a dielectric slab with dielectric constant K equals to 4. Full stop. Find new charge induced on the slab after the insertion. The question is that A capacitor of capacitance 50 microfarad. So your capacitance is how much? 50 microfarad. As your capacitance is 50 microfarad, 50 microfarad, and charged with a battery of 4 volt, charged with a battery of 4 volt, then after full charge, disconnect battery and insert a dielectric slab with dielectric constant K equals to 4. Now the question is that find the new charge induced on the slab after insertion. So charge induced on the slab, Q induced, that is Q1 minus 1 by K. So Q is CV, that is 50 into 4, that is 200 microcoulomb. So Q induced is 200 microcoulomb, 1 minus 1 by 4, that is 3 by 4 into 200 microcoulomb, that is 150 microcoulomb in the slab. And if the question asks you how much charge induced on the plate, so then you can write Q minus Q in, that is 200 minus 150, that is 50 microcoulomb in the plate. Everyone, is it okay? Very, very important. Suppose we have a parallel plate capacitor. We know the plate, this is the minus 1, this is the plus 1. We know A is the plate area, B is the separation. And we also know for the air capacitor, the capacitance is epsilon naught A by D. We know all this information. Now the question is that if we insert a dielectric slab whose dielectric constant is K and the thickness is T and the plate area is as that the plate area of the plate, find the capacitance of the capacitor. So I give you 1 minute, you can try, then you try this. Okay, so how you solve this type of question? See, first of all, the voltage, we know voltage is electric field into distance. So what we can say here, E is the electric field for the air medium, and the distance in the air is how much? D minus T. Is it clear, everyone? If the total distance is D, so the air portion is how much? D minus T. Is it clear?
Yes, sir.
Now, EM for that medium, EM into T for that dielectric slab. Now, just now we know that the E medium is E by K, just now from the properties of dielectric medium. So we can write E D minus T plus E by K into T. Now we know electric field for a parallel plate capacitor is sigma by epsilon naught, which we can say charge epsilon naught into area. So if we take E common, D minus T plus T by K, which is the Q by epsilon naught A, that is D minus T plus T by K. So C equals to Q by V, so Q cancel, epsilon naught A, D minus T plus T by K. Is it okay, everyone? Everyone, is it okay?
Yes.
But this is the derivation. If you want to know how you write this equation directly, I can give you a very shortcut method to write it directly. See, this is my formula, epsilon naught A by D. Epsilon naught A is common, so you can write epsilon naught A. Now, which part is in air? D minus T part is in air, plus the T portion is in the medium whose dielectric constant is K. Can we write in that way? Because AR means that K is 1 divided by 1. So divided by 1 is doesn't matter. So B minus T plus T by K. Is it clear, everyone?
Yes, sir.
Everyone, you all understand that part? If it is yes, now let's try one more question. Then you understand it much better form. Let it be T1, K1, and we insert one more plate, K2, T2. So then what is my final answer? My final answer is D minus T1 minus T2. Is it okay, everyone? Plus T1 by K1, T2 by K2. Is it okay, everyone? You understand how we write it? Everyone, is it okay? That part, especially. Say yes,
Yes,
or
sir.
no. Everyone, is it okay?
Yes, sir.
সবাই বুঝেছিস? দিয়া বুঝেছিস?
Yes, sir.
কি নাম ওই মেয়েটার? শিরিন বুঝেছিস?
Yes, sir.
Now see, if we want to derive it, maximum देखो एक तक ही derivation देता है, एक से ज्यादा चलो दो तक maximum देगा. So we can try this the same way. Total voltage, that is E, the air part, now D minus T1 minus T2 plus EM1 T1 EM2 T2. I think you all understand now what we can write. E is what? E D minus T1 minus T2 plus E by K1 T1 E by K2 T2. So if we take E common, D minus T1 minus T2, that is one part, T1 by K1, T2 by K2, that is the second part. Now we know E is Q by epsilon naught A, D minus T1 minus T2 plus T1 by K1, T2 by K2. So C is Q is CV, C is Q by V, that is epsilon naught A. This whole part we can write here, D minus T1 minus T2 plus T1 by K1, T2 by K2. Everyone okay? See, you get the same answer. If examiner asks you, similarly suppose, if examiner asks you, the plate like this, and you have 1, 2, 3, up to N, K1, K2, K3, dot, 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 Kn, T1, T2, T3, Tn. This one is plus, this one is minus. So your capacitance is, you can write epsilon naught A. No air space is there. As the no air space is there, so we can write T1 by K1, T2 by K2, dot, 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 Tn by Kn. Everyone, is it okay?
Yes, sir.
It's very, very important. See, if we use metal, then what happens? So this part is very, very important. If we use a metal, see, this is my parallel plate capacitor. This is my one part, this one is my plus and minus. This one is my external electric field. In presence of external electric field, if we introduce a metal, so what happened? In presence of, we know first of all, inside a metal, the amount of free electron is infinity, means ocean of free electron. That means we know inside a metal, the amount of free electron is ocean of free electrons. And we know at the same time this thing, in presence of electric field, if we introduce a negative charge, it moves in the opposite direction. So this electron, free electrons are move and concentrate in this side, as well as this electron move in this side. This one is negative charge, and this side is the deficiency of the electron, which we can say positively charged. Here, everyone. So what happened? Electric field is generated, as I already say you, let it be the induced electric field. But here it's not the partial charge. Here the electron, free electrons are moved, and as inside the metal, the amount of free electron is ocean of free electron. So within a very short interval of time, external electric field and induced electric field are equal. As the external electric field and induced electric field is equal, E net, that is E minus E induced, is 0. So that's why when you insert a metal, inside the metal, your net electric field is 0. Means external electric field equalize the internal electric field. So that's why the net electric field is 0. And that's why we know it from the properties of electric field that electric field inside the metal is always 0. This is the logic, this is the mechanism behind that. हमने बोला था, जब हमने प्रॉपर्टीज पढ़ा था, हमने बोला था अभी नहीं बताएगा, जब हम लोग डाइलेक्ट्रिक में जाएंगे तब ये ज्यादा अच्छा से समझ में आएगा. So now I think you understand, and from that dielectric constant is E by E net. So E external by net is now 0. So always remember dielectric constant for metal dielectric constant is infinity. Any type of metal. So that's why they can give you copper, iron, zinc, any metal, the value is infinity. Not a particular value, the value is infinity. So that's why they don't say you it's a metal, they just give a name, like they say you insert a copper plate. So that means your K is infinity. Now suppose in a parallel plate capacitor, this one is plus, this one is minus, and suppose this separation is D, plate area is A, and suppose we insert a slab, dielectric slab, which is metal. Whose thickness is T. So what about the capacitance? Epsilon naught A D minus T plus T by K, and here the K for metal is infinity. So anyone tell me something by infinity is how much? Hello? Something by infinity is 0. So your capacitance is epsilon naught A D by T. Everyone, is it okay? Hello?
Yes, sir.
Yes.
If it is okay, now please write a numerical. After that. Write down an air plate capacitor, of capacitance, air plate capacitor of capacitance 50 microfarad. Air plate capacitor of capacitance 50 microfarad. A copper plate of thickness D by 4, a copper plate of thickness D by 4 with same plate area inserted between a parallel plate air capacitor like this. Find the capacitance of the capacitor. Find the capacitance of. So what is the answer? Hello. Hello. What is the answer? Anyone please tell me? Am I audible? Answer. See, it's a very simple question. C is the air capacity, that is this much. So C is epsilon naught A D minus T as I write the formula. Now here it is given T equals to D by 4. So epsilon naught A T minus D by 4. So how much you have? Epsilon naught A 3 by 4 D. So 4 by 3 epsilon naught A by D. Now 4 by 3 epsilon naught A by D is 50 microfarad. So you have 200 by 3 microfarad. Done, everyone? Is it okay?
Yes.
After that, the next one, very important. देखो ये भी क्वेश्चन बहुत बार एंट्रेंस एग्जाम में पूछा है. Like suppose you have a parallel plate with here then K1 then metal then K2 again here. This one is D, this one is D, this one is D, this one is D, this one is D. So my question is draw electric field versus distance graph. This is D, this is 2D, this is 3D, 4D, this is 5D. Find this question. You can draw how the electric field look like here. It is given K1 is greater than K2 for the air part. As the dielectric constant is 1, so my electric field is maximum. So in this part, let randomly we choose the electric field is maximum. Let the maximum value is this one. First one and last one is the air. So in the first one and last one, my electric field is maximum and fixed. So these are the, and why this one? Because we know in case of parallel plate capacitor, electric field is fixed value and a constant value, uniform, and it's a maximum because the medium is air. That medium is air. Now the second one is K1. K1 is greater than K2. If the K1 in K increase, so net electric field decrease. So let this one is K1 and this one is K2. As the K1 greater than, so electric field is less one, this one is electric field is greater one. And here you have metal, here you have metal, here you have metal. This one is the metal. In metal, as your K is infinity, so electric field is 0. So we can say here, this one for K1, here this one for K2, and this one for air. So this type of question, like this 3 metal, K1, K2, air, they give you in the entrance exam like IIT or NEET exam. Always remember for air it is maximum, for metal it is 0, and if you have K1, K, so it is K times decay. So we choose these two value randomly, and as K1 is greater than K2,
So this one is less than this one. Here, everyone?
Yes.
Is it the next one? The next one is very, very important. Next one is again a theoretical concept on the basis of which once a numerical ask in IIT exam and the same type of a numerical ask in board exam also. Only the difference is in board exam they just give you the value k, and in entrance exam they give you the value of k4. So in the next time they maybe give the value of k. So for that, how you solve this type of question? For that, the strategy is that you can write down the numerical solving strategy. Case one, case one, case one. Suppose we have a capacitor C, we charged it with a battery of voltage V. Suppose we have a capacitor C, we charged it with a battery of voltage V. So the charge store is CV. So the charge store is CV and energy store is half CV square. Energy store is half CV square. C is the capacitor, V is the voltage. Is it clear, everyone?
Yes, sir.
Now, after full charge, disconnect battery. Disconnect battery. CO, no? Disconnect battery and insert a dielectric slab. K with dielectric constant K. After full charge, disconnect battery and insert a dielectric slab with dielectric constant K. So this is my case 2. What happened? If after full charge, we disconnect the battery and insert a dielectric slab whose dielectric constant is K. So now what happened? Now, what changes are there? As we as we insert some dielectric slab, so my capacitor is now K times increase, because we know capacitor depends on the medium, plate area and separation. It does not depend on voltage. It does not depend on the charge store. So K times increase. And as it is a open, means it does not connect with anyone or it's not connected with a wire. So it is an open circuit. So in open circuit, the total charge will remain conserved. So my previous charge is equals to my new charge. They are equal. So my from the previous charge, we can say my capacitance is C, voltage is V, but now my capacitance is C1, voltage is V1, and as we insert some slab, my capacitor K times increase, so my voltage CC cancel, K times decrease. As we also know, the electric field also K times decrease. Just now we see when we insert some medium, electric field K times increase, and voltage and electric field is E equals to VD. So if the electric field K times decrease, my potential also K times decrease. So my potential K times in decrease. So my energy store half C1 V1 square, half C1 is my C1 is Kc and my V1 is V by K square. So what we have half CV square by K. So my energy store K times decrease, half CV square by K. Is it clear? So that means we can say with respect to initial energy store, my energy store K times decrease. When we remove the battery and insert a dielectric slab with dielectric constant K. Now case 3, what happened if we not remove the battery and insert a dielectric slab? So if we not remove the battery and if we insert a dielectric slab, means it is connected with the voltage V and my dielectric slab, if I insert a dielectric slab. So what happened then? So many changes are then happen. First of all, capacitor does not depend on voltage and charge store. So my capacitor is remain K times increased with respect to the first one. But now my voltage, which is in the previous one, K times decreased as we not maintain it with a voltage. Now, as we maintain it with a voltage V, so my new voltage is maintained by the battery, which is V. Is it clear, everyone?
Yes, sir.
So my new charge store is C2V2. So we can say KCV. So this type of question also asks if initially a capacitor with capacitance C charged with a battery of voltage V, after that you not remove the battery, but if you insert a dielectric slab, then your charge store is KCV. So they can ask you how much new charge supplied by the battery. So del Q is the new charge supplied by the battery, that is Q2 minus Q. So you can write CV is the previous one, CVK minus 1 is the new charge supplied by the battery after inserting the dielectric slab. Okay, and now the energy store, that is half C2V2 square. So half my capacitance K times increase, but my voltage remain as it is of the first one. So my formula is half K CV square. So I can say my energy store K times increase. Is it clear, everyone? Now let's try a numerical. Let's try a numerical. The numerical is that suppose you have a battery of voltage V connected with a capacitor C, and you have a switch which is initially on with another capacitor C. This is the thing. After full charge, switch off. After full charge, switch off and insert dielectric slab with dielectric constant K. After full charge, switch off and insert dielectric slab with dielectric constant K equals to 4. K equals to 4. That K equals to 4 ask in IIT exam, and just K ask in board exam. So they are same thing. K equals to 4. Insert in both the capacitor, means after switch on, now you full charge, you switch off it and insert dielectric slab in both the capacitor. After switch off, insert dielectric slab in both the capacitor. Now the question is total energy store when the switch is on, and when the switch is off. Find the ratio of energy store when the switch is on and when the switch is off. So I give you a basic question. See, initially, suppose no dielectric slab is there, and obviously the switch is on. So this is the case 1. Very simple, case 1. So your capacitance is half CV square. So yes, when the switch is on, half CV square plus half CV square, that is CV square. Tanya, very good. Now in the second part, I think you made a mistake. This is you insert, but now your switch is off. As the switch is off, now see clearly this one connected with the battery. So you can say this is the case 3, and this one is not connected with the battery. So this one is case 2. Are you noticing, everyone? You notice that part? This is connected with the battery. So case 3, and this one not connected with the battery. So case 2. So as this one not connected with the battery, what happened? Energy stored K times decrease, and as it is connected with the battery, energy stored K times increase. You notice it, everyone?
Yes, sir.
So if you notice it, then what is your energy store when the switch is off? Half CV square. If you take common, here you K plus 1 by K. So what happened? Half CV square, K square plus 1 by K. Now, when the switch is on, when the switch is off, your CV square by half CV square, K square plus 1 by K. So CV square cancel. So basically you have 2K by K square plus 1. That is for the board exam. And for the entrance exam, they give you the value of K is 4. So 2 into 4 by 16 plus 1. That is 8 by 17, not 1 by 16. Got it, everyone? So I'm